All right, so now let's do the second question, and I'll go a little faster in this one. Um, so here we have the game on the left, we have the game on the right. So player one does not know, player two does know. So again, player two has the more complicated strategies. So I've already created the play table. So we've got player one strategies are just D or W. For two, it's either draw, 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 wait, wait, draw, or wait, wait. And so now our challenge is just to fill out this table. So this one's for me a little trickier because it's not half and half, so we have to be a little bit careful. The game on the left occurs 3/4 of the time. The game on the right occurs 1/4 of the time. But just as before, we're going to pick a particular box, and then we're just going to figure out what the payoffs are. So might as well start with box in the upper left. So draw, draw, draw. So the game on the left, when both draw, the outcome is 2/3. The game on the right, when both draw, the outcome is 5/2. So for player one is getting 2 times the probability the game on the left occurs, which is 3/4, plus 5 times the probability the game on the left occurs, which is 1/4. So we have this 6/4 plus 5/4, that's 11/4. Now for player two, we don't have to do the expectations. The game on the left, getting 3, and the game on the right, they're getting 2. So next box is similar. So if we're looking at draw, draw, wait. So in the game on the left, we're doing draw, draw. Everything's exactly the same. In the game on the right, now we're doing draw, wait. So the outcome is 4/1. And so what player one's getting is they're getting 2 3/4 of the time. And now they are getting 4 1/4 of the time. So player's getting is 2 times 3, 6 plus 4 more, so 10/4. It would be a good form to simplify it, but we don't have to simplify it. That's not essential. For player two, okay, so player two on the left is getting 3, on the right is getting 1, and so that's what we fill in. So I'll do one more, and then we'll fill in the table. So if, for example, let's do W, DW. So in the game on the left, player one is waiting, and player two is playing D, drawing. So wait D, the outcome is 1/4 on the left. On the right, both are waiting, and so the outcome is 8/4. So if we have 1 times 3/4 plus 8 times 1/4, then our expected payoff is 3 plus 8, so that's 11/4. Player 2 is getting 4 in both of these situations, so their payoffs just look like 4/4. So we fill in the rest of the table in a similar manner. And what we're going to get is as following. Okay, so hopefully I didn't mess that up. And if I didn't, then these are the numbers that we would get. So now we're doing the best responses. So let's start with player one. So best response to draw, draw. We have 11/4 or 7/4. I made my box a little too small, so rather than underlining, let me circle. So the best response to draw, draw would be 11/4. Best response to draw, wait, I'm either going to get 10/4 or 11/4. So 11/4 is the best I can achieve. Best response to wait, draw, I'm either going to get 14 or 30. So waiting is the best I can achieve. Now I have a choice between 13/4 or 8, and so 8 is the best I can achieve. Now let's do this for player 2, but the player 2 who knows it's the game on the left. So again, we'll circle instead of underline just because I ran out of space. So if player 1 is going to do draw, player 2 can either get, on the left, can either get 3, 3, 1, or 1. So the best player 2 on the left can achieve is 3. If player 1's going to wait, player 2 is either going to get 4, 4, 2, or 2. So the best they can achieve is 4. Now we look at player 2 on the right. And so if player 1's going to do draw, player 2 can get 2, 1, 2, or 1. So the best they can achieve is 2. If player 1 is going to wait, then player 2 can get either 3, 4, 3, or 4. So the best they can achieve is 4. So interestingly here we have 2 Nash equilibria, 2 pure strategy. And so the Nash equilibria are either draw, 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 or wait, draw, wait.